You ever wondered what's really going on deep beneath our feet? It's not just dirt and rocks down there. Earth's interior is a blazing hot, high-pressure world, and sometimes that world bursts out onto the surface in one of nature's most spectacular displays, a volcano. But what exactly is a volcano, and how does it even get there in the first place? Let's dive in and find out. Imagine our planet like a giant peach. We live on a thin skin, which we call the crust. Beneath that is the juicy flesh, the mantle, and at the center is the hard pit, the core. The mantle isn't solid rock like you might think. It's so hot that parts of it are a thick, flowing substance called magma. Think of it like super hot, gooey honey. This magma is less dense than the solid rock around it, so just like a cork in water, it wants to rise. Now, Earth's crust isn't one solid piece. It's broken up into huge sections called tectonic plates. These plates are constantly, slowly, drifting around on top of the mantle. And this is where things get interesting for volcano formation. There are three main ways this movement can create a volcano. First, let's talk about divergent boundaries. This is where two tectonic plates are pulling apart from each other. As they separate, it creates a gap. This reduces the pressure on the mantle below, allowing it to melt and form magma. This magma then wells up to fill the space, often creating long chains of underwater volcanoes. This process is happening right now along the Mid-Atlantic Ridge, literally building new ocean floor. Most of this action is hidden deep beneath the waves, but in places like Iceland, the ridge rises above sea level, giving us a front-row seat to this incredible geological process. That's why Iceland is known as the land of fire and its packed with active volcanoes. The second, and perhaps most famous, way volcanoes form is at convergent boundaries. This is the opposite of divergence. It's where two plates are crashing into each other. When an oceanic plate collides with a continental plate, the denser oceanic plate gets forced underneath the continental plate in a process called subduction. As the oceanic plate sinks deeper into the mantle, the intense heat and pressure cause water trapped in the plate to be released. This water lowers the melting point of the surrounding mantle rock, creating buoyant, sticky magma. This magma then forces its way up through the continental crust, eventually erupting to form a volcano. The iconic ring of fire that circles the Pacific Ocean is packed with these kinds of volcanoes. Like Mount St. Helens in the United States and Mount Fuji in Japan, these are the volcanoes we often see in movies, cone-shaped, explosive, and truly awe-inspiring. But what about volcanoes that are nowhere near the edge of a plate? Hawaii is a perfect example. It's a chain of volcanic islands right in the middle of the Pacific Plate. So, how did they get there? The answer is hotspots. A hotspot is a fixed spot deep within the mantle that's unusually hot. Think of it like a giant blowtorch pointing up at the Earth's crust. This intense heat melts the rock above it, creating a plume of magma that punches its way through the crust to form a volcano. Here's the cool part. The tectonic plate keeps moving over the stationary hotspot. So, the hotspot creates a volcano. The plate moves, and the volcano is carried away from its magma source, becoming dormant. The hotspot starts working on a new spot on the plate, forming a new volcano. Over millions of years, this creates a long chain of volcanic islands, with the oldest ones being furthest from the hotspot and the youngest, most active ones sitting directly on top of it. The Hawaiian Islands are a classic example of this assembly line of volcanic creation. So, we have magma rising from the depths. What happens next? This magma collects in large underground pools called magma chambers. It's like a waiting room for an eruption. As more magma pushes in, the pressure inside the chamber builds and builds. It's like shaking a soda can. Eventually, the pressure becomes so great that it fractures the rock above it, creating a pathway to the surface. When that magma finally breaks through, we get a volcanic eruption, floods. Once the magma reaches the surface, we no longer call it magma, we call it lava. Along with lava, eruptions can blast out ash, rock fragments, and gases. The type of eruption depends heavily on the magma's composition. Magma that's thin and runny, like the kind found at hotspots in Hawaii, allows gases to escape easily. This leads to gentle, flowing lava that can travel for miles, building up broad, shield-like volcanoes, or magma. At subduction zones is often thick and sticky because it has more silica. This thick magma traps gas bubbles, causing pressure to build up dramatically. When this pressure is released, it's not a gentle flow. It's a violent explosion. It shatters the magma into tiny particles of ash and rock that are blasted high into the atmosphere, creating those classic steep-sided composite volcanoes, or stratovolcanoes. Over time, with each eruption, layers of lava and ash build up around the central opening, or vent. This is how a volcano gets its iconic mountain shape. It's a structure built entirely by its own fiery output, eruption after eruption, over thousands or even millions of years. From the deep ocean floor to towering continental peaks, every volcano tells a story of the immense power churning just beneath our feet. So, to recap, a volcano is essentially a vent in the Earth's surface that allows molten rock, debris, and gases from the planet's interior to escape. They are formed primarily at the boundaries where tectonic plates pull apart or crash together, or in the middle of plates where a superhot plume from the mantle creates a hotspot. Each eruption adds another layer, slowly building these magnificent and powerful geological wonders. They are a direct link between the world we live on and the fiery, dynamic world hidden below. It's a powerful reminder that our planet is not a static ball of rock, but a living, breathing system that is constantly changing, building, and reshaping itself. And volcanoes are one of the most dramatic expressions of that incredible energy. Thanks for joining me on this journey into the heart of a volcano. If you found this fascinating, be sure to hit that like button and subscribe for more deep dives into the wonders of our world. See you next time.